So I'm Petter Johansson. I'm from the Cognitive Science Department. Here in Lund is actually placed under philosophy, so I'm part of the humanities, but I'm very much an experimental psychologist. And I run what we call the Choice Blindness Lab together with Lars Hall, and we'll present some of that research today. And what we're interested in, broadly speaking, is sort of the relationship we have with ourselves, and especially sort of our guiding hypothesis, or a lot of the work we do, the centers around this idea that yes, we have a lot of self-knowledge, but a lot of this knowledge actually comes from self-inferential processes. We observe ourselves. We listen to our own, what we say, we see what choices we make, and we make inferences from this. And from that, we build sort of our self-knowledge. So, of course, we have the ability to look in and sort of observe our own thought process to some extent, but to a much larger extent than we often think. This is sort of, we have a relationship with ourselves that is similar to the relationship we have with other people, basically. So we look at ourselves, see what we do, figure out what it means. And I'll talk about 4 different studies today, or 4 different types of studies. And they all have this in common, more or less. Right. So we'll start with choice blindness, which was sort of the first set of studies we did. So if you're interested in self-knowledge, one of the main problems you have is how to establish an independent measure of truth. That is, how can I know when someone is right and when they're wrong about themselves? So we've all had this experience when we talk with a friend, someone we know well, that they explain a choice they made. We ask them, so why did you do this? And they give these long, elaborate explanations for it. And to you, it can feel that something here isn't right. There's something off in this explanation, but there's no way you can prove that to be the case. And that person can be perfectly sincere and genuinely believe that this is the right reason for why I made this choice, but there's no way you can sort of challenge someone's assertions about themselves. So this is what we wanted to challenge. We wanted to create an experiment in which we would know from the outside when people are right and when they're wrong about themselves. But tricking people about their own mind is hard, so we consulted with the experts, the magicians. So they are experts at controlling people's attention, but also experts at giving the illusion of a free choice. So when they say, pick a card, any card, the only thing you know that your choice is no longer free. So we had a few fantastic brainstorming sessions with a group of Swedish magicians, and they helped us create the first kind of experiment, sort of capturing this, what we were looking for. So I'm going to show you a short movie illustrating this experiment. It is a little bit silly, but it kind of shows the experiment, so bear with me. We'll see if we can get this right.
But there's another problem. These men have discovered that sometimes your brain appears to conspire against you.
And no amount of scribbling can solve that. Petter Johansson is forcing people to make decisions.
This one.
It's a simple enough task for most people, and in fact, it isn't the real point of the experiment.
Why did you prefer that one?
Higher cheekbones, slightly better hair, not much between them.
Petter Johansson and Lars Hall have devised an experiment which calls into question many of our assumptions about how we make most of our everyday decisions.
We're interested to see what kind of detail the representations behind people's decisions and what kind of insight they have about those decisions.
Why did you choose this one?
It seems like he'd be someone with a very interesting personality.
This is all quite boring, until you look at the experiment from a different perspective.
This one.
We added a twist, a card trick, so that sometimes they choose one face but end up with the other one.
Watch carefully. The volunteer chooses the card on the left,
This one.
but Petter swaps the card and presents the photo that was seen on the right and was actually rejected.
It is a card trick, but it's a cheap card trick, based on something that the magicians just call black on black. So for each card, there's a hidden card behind it, which is actually the opposite one. Where we slide the other card over, the black card is hidden. And then Petter just uses his arm to slide it down into his lap.
I mean, it's two parts that's interesting here. First, the fact that they don't notice when you switch the pictures. It's interesting in itself, and it's quite surprising. And the second part is, of course, the verbal reports they give, that they actually motivate choices they didn't make.
80% of the people we tested had absolutely no idea that a switch had been made.
Again, this one just struck me. Interesting shot. Since I'm a photographer, I like the way it's lit and looks.
It's a puzzling phenomenon.
Lars and Petter.
Right. So you kind of get where this is going. So I let them make this simple decision. They look at the images, they pick it up and ask, so why did you prefer this one? And as they stated in the movie, very few people actually detect this. So that's a sort of the first set of findings. But today, what's more interesting is, of course, the verbal reports they give. How they explain this choice when I ask them, so why did you prefer this one? And we've done a lot of analysis on these types of reports. And one first striking finding is, if we compare what people say in a manipulated trial with what they say in a non-manipulated trial, not actually just get what they want, we find very few differences. So here is just comparing, will independent raters look at all the reports, rate how emotional are these statements, how specific, with how much certainty are they expressed, and they're very similar. And they say things like, her appearance make her look charming, a great character, or she looks very serious, and that was easy, she looks happy, energetic, and so forth. Even when they get the opposite of the choice. So they instantly construct reasons for a choice they didn't make, what we call confabulation. But what makes this even more interesting, and if you're interested in self-knowledge and this sort of self-inferential perspective, is, okay, can we also tie these reports to show that it was really constructed after the choice, not beforehand and remembered? Because faces are kind of similar, so it could have been that these are rehearsed, right? And then we find sort of gems like this one. So in this case, the participants preferred this face, ended up with this one, and explained why, saying, she's radiant, I would rather have approached her at the bar than the other one, and I like earrings. And if you look at this, the only reason, this can't have been the reason for having preferred this face, because the earrings sit here, of course. So here we have sort of constructed the experiment in order for us to be certain from the outside that what they do is a sort of post hoc explanation. But they're not aware of this themselves. They think this sort of is an immediate introspective report. So I'm not going to talk more about choice blindness. We have done tons of these kinds of studies with political statements and consumer choices and so on. And we regularly find this kind of pattern. But one thing that's interesting today is just to mention that if we let the participants do these choices again, they often change the preference. So they now prefer the face that we just led to believe they liked. So if they hear themselves construct an argument why this is the preferred political opinion, this was the preferred face, this was the jam I liked, we did studies down at the supermarket, this also changed their preference. So they listen to their own voice to find out what they want, at least to some extent. Right. So now I'll present another study which is a little bit more towards sound and voices. So if the first set of experiments were sort of named choice blindness, we had to name this one voice blindness, even if it's not very informative, but it rhymes. And right. So this study I will present next was sort of it was done by my former PhD student Andreas Lund, and he had as starting point this famous quote by Forrester that says, "How do I know what I think until I see what I say?" And this one often surfaces in discussions of self-knowledge, or in the sense of that people are often surprised when they hear what they say, or there is knowledge in having conversations with other people because it sort of forces things out of your brain that you're not aware of. But he thought, okay, taking inspiration from this quote and many other things, he said, okay, but what would happen if you said one thing but heard yourself say something else? So you'd speak, but what came into your ear would be something different. So even if we have quotes and sort of ideas like this, the standard models of speech production, they very much rely on that speaking starts with a very well specified pre-verbal message that are then just step by step used by the brain to be sort of put in words and then sent out. And you have monitoring mechanisms going on and on and on to make sure that what you intended to say is what actually came out. So from a standard perspective or standard models of speech production, if you said something but heard yourself say something else, the alarm bells would immediately go off. But on the other hand, if you have a more self-inferential perspective, where you actually listen to your own thoughts, what you know your own speak, and look at your own behavior and your own actions and make inference from it, maybe the fact that you hear yourself say it would be evidence enough for you to accept it at yours. So this was the sort of reason why he wanted to pursue this in his PhD. This is just to remind me that I should mention that, right? So how would you do such an experiment where you could substitute what someone said in real time? Anyone that has done anything with voices, or anyway, you could just guess that it's a little bit tricky to get this to work. So first of all, you need to create or set up a predictable speech situation, a situation in which you, as an experimenter, know exactly when someone is going to say something. You will also want to know what they're going to say, so you can exchange it with something that makes sense. You also need a setup that makes it possible to insert the other word exactly at the right time, so there's no gap in it. And then, of course, you also need to block the ears as much as possible, so they can't hear their own voice when we insert something else. So that was sort of a requirement to make this work. So how did we do this then? Right. So we used the standard experiment in cognitive psychology known as the Stroop task. So the task here is it's to, when you see a word on the screen, you should ignore what it says, but say the color it's written in. I hope I got that right. So here you should say blue. Here you should say brown. But the task is to do it as quick as possible. So there is a little bit of an interference between these two. So it's one of the standard classic findings in cognitive psychology. Had this one been blue in blue text, you will do it quicker than if there is this mismatch. On the other hand, you almost always get it right. So there is a sense of confusion maybe, but you can do it. But by doing this, we also can learn how quickly after the onset on screen they're going to speak, roughly. So we know, we have sort of control of the when they're going to say it and what they're going to say. So we let people do this Stroop task, and then in a hidden room next door, Andreas Lind, sitting in the darkness, he then records them when they say green and red and blue and so on during the experiment. And then he trims that sound file. So he creates a sound file that starts exactly at, you can actually see it here, at the onset of, or at the start of a clip. And then he loads it into a player, which is then triggered by a sort of voice triggered. So when the voice of the participant reaches a threshold, this clip is going to be played. So he do the trimming, insert it, he picks something they've said previously, so it's their own voice, and he set it up so it can be played using this gamepad. Right. So in the experiment, the participant will be presented with here, this one. It's green, so they're supposed to say green, and that's what they do. They have a noise-cancelling headset that Andreas has built, which they use when they drive tractors and then insert mics and stuffs in it. But what they hear is grey. And then come the crucial bit. On screen comes a question saying, what did you just say? To see what they're going to, which one they're going to go with. So in the experiment, we just follow the standard protocol for a Stroop test. So they quite rapidly, bam, 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 they do these words. I think this takes about 10 minutes. In 4 of the trials, we insert grey instead of green, and in 2 trials we do green instead of grey. And we did this in Swedish, I think, so it's grön och grå och grå och grön, but it's roughly the same. So the onset is the same, but the meaning is different. And then we also had 4 non-manipulated trials for comparison. And during these trials, we would also ask them, what did you just say? So we can get a comparison for this effect. Right. So first of all, what we would then call voice blindness. What happens? Do people immediately detect this and reject it? Or what happens? So here we find that when we manage to get ideal timing, the detection rate is around 30%. So here it's also divided into various levels of certainty in the detection, how much they express and so on. But we can also see that it's a big difference when we have this perfect timing and when it's outside the timing window, because sometimes they do some smacking noises or hesitate or something. So the voice, once we've loaded it, the voice trigger is just going to go whatever they do. But roughly, okay. So there is a large proportion of trials in which they don't detect this clearly. But the more interesting question again is, of course, what do they say when asked what did what do they answer when they say what did you say? Here are the results of this one. I'll walk you through it because it's a bit counterintuitive. So we have first a large proportion of trials in which they hear grey, or the opposite, and when asked, what did you say, they would say what they heard themselves say, right? So in these cases, they clearly have taken that as their own production. And then there are a number of trials in which they immediately correct themselves, because what they hear is the wrong answer, right? So they say what they're supposed to be, but they hear the wrong one. So they react to it as if they've said it, right? No, I mean grey, because they thought they said green. And then there is a number of trials in which they said green, they said grey, but in retrospect said, yes, there were a few times when I got that prompt when I corrected myself. So I said when you asked what did you say, I said what I was supposed to have said, rather than what I heard. And then there were a number of trials that I just said grey and hadn't really absorbed what happened. Right. So this is sort of our first endeavor into messing around with sounds and voices and so on. Here, of course, this line of research is a little bit fiddly and tricky, but we have done a few follow-up studies, but it's ideally you would have loved to do this in a natural conversation back and forth and just bam, snap it in, or do an where the problem with the Stroop is that it's such a clear right and wrong answer. You would have like a more open-ended, maybe where there is sort of a like there's one letter missing and you can fill in what word you think it is, and there are a number of different words, that kind of thing. There are reasonable follow-ups that we haven't done for various reasons, but it's in that direction, having a more semantic complexity we would like it. But anyway, to some extent, it shows that we actually listen to ourselves to find out what we mean. We don't only rely on an inner representation of our speech intention, we actually listen to our own voice to see how I react to it, and then we react to it the same way. The next study or approach I'm going to present is what was advertised in the presentation and maybe why you're here. It's taking this, so far we've messed with the intention of the participants in their motor and decision intentions, here with the vocal intentions. Here is to see, okay, what can we do with the emotional expression in their voices? So this is work done very much in collaboration with Jean-Julien Aucouturier. He's a fantastic French scientist I met when I was a postdoc in Japan. And he's an expert at audio processing, and together we started the research I'm going to talk about next. Right. So a little bit of background. So emotions is a quite complex topic in psychology, because emotions have many different components and also many different theories of what emotions are and how they function. So they have both a physiological aspect, sort of your heart rate goes up, your sweating increases and so on. You have the expressive component, what you actually signals to others when you change your face into frowning or smiling. It's meant to convey your emotion to someone else, and that has a certain purpose and an effect. And then, of course, there's also the subjective component, the things you feel, if you feel sad or angry, and so on. One of the classic debates in psychology is between what you would call sort of a common sense approach to emotion, in which you first feel sad, you have the feeling, the inner subjective feeling comes first, and then that is sort of propagated into expressions. So you signal what you feel inside, and your sort of your heart rate and sweat and so on follows the emotion you have. But then there's also what's known as sort of an attribution theory, which is which basically argues that sometimes it's the other way around. So you feel your pulse go up, and you feel this tingling in your hands. You look around you to find an explanation why your body reacts, and then you create an understanding at some level of your cognitive machinery of what is it that triggered this reaction. Is either that bear scaring me, or this woman on a high bridge, classic example, sort of where you sort of what is it that made me feel this way, and after that the emotion is felt, basically. So it goes the other way around compared to common sense. Here, one of the classic studies is known as the facial feedback hypothesis, or these kind of experiments. So here you trick people into in the original study, they looked at cartoons, and with some clever deception, they were told to either look at the cartoons holding a pen with their teeth, like this, or with their lips. And the idea was, of course, that this, when you trigger smile, the muscle, the signals from the muscles would go backwards up to the brain, tell you you're happy. Therefore, this cartoon is funny, and so on. And they're saying they've had versions of this where you should make these two dots go together, so you frown when you do something. So unfortunately, this famous study with the cartoons doesn't quite replicate, but they've done versions and other variations of this facial feed. They've done fantastic ones with Botox, where they sort of make your face paralyzed and that influence your emotions and so on. Anyway, so this is the sort of background theory of emotions that we're going to tap into next. Okay, so again, we start with a question. Can we do this with a voice instead? So the problems, if you want to go with the voice to see the impact the voice has on a speaker, if you want to do experiments, is to isolate the effect of the feedback. So they've done experiments in which they have actors, they're told to display a certain emotion in their voice. So they're going to read a story sounding happy or angry or something. The problem there is, of course, you can't isolate the effect of the production as such. You tell them to sound angry, and maybe the process of sounding angry makes them angry rather than just listening to their own voice. So you want to isolate just the hearing the voice. And it's the same if you would have them read a sad story to make them sound sad, but then you don't know if it's the sadness of the text that influenced them, and so on. So doing it with real participants without any sort of manipulation is tricky if you want to isolate just the sound. Also, it's hard to create a natural situation in which you would feel natural to read with a loud voice or to express anger and so on. And above all, in all experiments, if you're not into psychology but might have guessed now, one of the biggest, most important aspect is to hide the true purpose of what you're doing. Because if the participants know that you're looking for this effect, you're never going to know if it's some sort of demand effect that's in play. So you have to hide the true purpose in order to see what the effect is. So of course, we then went for the artificial manipulation of the voice. Again, a set of requirements. We need to do some processing of the voice that leads to identifiable emotional changes. It needs to be non-transparent, so they don't understand that we're doing it. It's got to be made in real time, like you have to speak and hear your voice all the time, and it has to sound natural. So it must sound. It can't sound artificial, even if it sounds a bit angry. But you can't sound like a robot. So we need to construct an emotional effect that, while undetected by the speaker, can still be discriminated as an emotion by a listener. Right. So this is what we need to do. So when we first started to dabble with this, me and JJ, we just bought, we had the idea, we bought this sound effect box from somewhere with knobs on it, where you can play around with pitch and other things. I found this picture in an old presentation when preparing this one. I love this. So this is an instruction for a research assistant, and it says headphones cables as long as possible you need to find in order to run the experiment. Anyway, so this is where we started, but we're taking it a bit further after this. But now I'm going to play these effects And they're a little bit subtle, but we'll see if we can hear. The sentence I'm going to read is a bit weird, but I'll explain why in a little while. Let's see if this works. So here's the neutral one. There we were, me clutching the steering wheel, she in the navigator's seat, the two of us scanning the streets like hungry eagles in search of prey. And then we add an afraid effect. There we were, me clutching the steering wheel, she in the navigator's seat, the two of us scanning the streets like hungry eagles in search of prey. You can get a feeling of this, and then compare it to a sad effect. There we were, me clutching the steering wheel, a little bit she in the navigator's seat, the two of us scanning the streets like hungry eagles in search of prey. A bit compressed, and then a happy effect going. There we were, me clutching the steering wheel, she in the navigator's seat, the two of us scanning the streets like hungry eagles in search of prey. So I would say they're clearly distinct, but they can't be too dramatic, because otherwise, the game is up. They will hear that you manipulate them. So here, just roughly what we did with the voices. As you could hear with the afraid voice, we added like a bit of vibrato. Inflection is sort of making it sort of jump a bit more up and down. It's not a constant. So like for the happy effect, we also have a constant upshifting. So it's, I don't remember if it's 50 cents or something. Sad, we lower it a bit, and then there are a number of sort of filters that makes it a bit brighter or a bit darker, more compressed. So this is first we did this, which is sort of how the box did it. We don't quite know, but we just follow this. But we have then done a digital version. But right, so here's where we started. These were the effects. Then to evaluate, we had people listen to these voices and effects, like you did, and rate them on different adjectives. I think we used some sort of scale used by some other emotion researcher. These adjectives factored into two basic components, like positivity and tension. And then we looked at these three effects we had built. So when other people listen to this, they would say that the voice had increased in positivity when and reduced in tension when playing the happy. In sad, the positivity was clearly down, and for the afraid voice, the positivity was clearly down and the tension up. And this is kind of the pattern you would expect when you have people listen to it. So okay, this is fine. This means that the effect is kind of working to the extent as it did with you. You may hear these effects. Then we constructed this feedback experiment. So in this, we let the participants read a story for 12 to 14 minutes while we gradually increased the effect. So it wasn't full on, but after 3 minutes we gradually ramped it up. It was the second bakery attack of Murakami. That was the sentence I read was from that story, which is an ambiguous, it's not scary and it's not, it's a bit unclear what the story really tells, the emotion you should feel in it. Because we want one with room for interpretation, basically. So they read this, we gradually changed the voice. They listened to their voice with the same headset as Andreas had constructed, so they would hear it through this, and it get more and more into the effect. So they tested themselves on this emotionality scale first. They did the reading. We also had skin conductance on while they read, and then we had a post-test score and a debriefing. Right, so first of all, the detection rate. Very few people said you changed the emotion of my voice. So we had this in 3 different levels as the previous experiment. A few more participants said, well, you did something to my voice. There's something funny going on. A few more said, well, my voice sounded strange. But it was due to the headphones, so like the normal feeling you have when you hear your own voice and you don't like it, basically. And then the large proportion said, well, my voice sounded as always. So we managed to establish the first step, which is sort of showing that it's not the case that we have a strong emotional intention that we emit and then constantly monitor it in order to keep that emotion. We also, the voice is that aspect is not always part of your self-monitoring mechanism. But what happened with the emotion they then had felt while or after the reading? So here we find some level of result. So this is sort of the pre and post score. They did an emotions questionnaire before. They did it afterwards. We find some sort of increase in the happy effect on positivity. We find a decrease in positivity in sad. And we find a similar pattern in afraid, even if it's not significant. So we get some sort of level of emotional feedback and emotional congruence with the voice they've heard themselves. And then we look at the galvanic skin response, or the skin conductance level. So here we measured it over time, normalized to the onset of the manipulation. And what we find is that the control condition, you gradually adapt and get used to what you hear. But that sort of progression over time is distinctly different in the manipulated conditions. So this also shows that you somehow, there is no clear separation between the effect, but the system has incorporated and used this the emotional sound in your voice as part of, and it influences your psychophysics, basically. Right. So that was the sort of feedback experiment we did. Then JJ and his team he set up at IRCAM. They've turned this into sort of playing with boxes into a full digital working tool called David, which you can just download and play with. There are specifications what kind of sound cards and stuff you need, but you don't need an effect box anymore. So together we also did a research methods paper explaining all the details of this. Also running it on different languages, which was quite interesting to see if the emotions were, if you apply the same effect to a speaker in French, Japanese, English, or Swedish, if it was as discernible, the emotions. It turns out it worked the least in Swedish. And I don't know if it's our more sing-songy kind of going up and down from the start, or there are differences. But it's, and of course, perhaps it was not no coincidence it works best in French, because we sort of started with French and Japanese language when doing it. Anyway, but it means that it kind of works in many different languages. And this is interesting from a researcher in emotion kind of perspective, because the universality of emotions is one of the big things, and so on. I think the 3 steps here is just 3 different levels of the manipulation. So small, medium, and high. And we can see that it's more detectable the bigger it is, basically. Right. So using this, of course, there are many things you could play around with, staying with this sort of self-inferential perspective. you can do an experiment in which you to see what effect emotion have on a memory, retelling a memory while you apply an emotional effect to the voice. Will the next time you retell this memory, will it be sort of colored by the emotion in the voice you had when you retold it? That would be a very interesting finding. You can do things like having reading to moral vignettes or headlines or something, and then you estimate the wrongness of the thing of this scenario. If you then apply emotional voices to it, see if that would influence how bad, with the same logic as before. So reading a moral story, if I hear my own voice react with disgust, will I also then evaluate this as being more morally wrong, and so on, to find out what kind of cues do you use in this type of. Of course, you can enhance your performance in karaoke if you add fantastic vibrato or a sadness and so on. My friend Lars, he really wanted us to do this with sort of, if you could have this, imagine you play a sort of scary computer game like Silent Hill or something where it's like horror, and you talk to your friends and you hear your own voice like this, and that would probably sort of increase the sort of experience of it. But yeah, you can imagine all sorts of things. And of course also if you are a, what call it, when you call and try to sell things, you would like a happy voice and trustworthy and so on. So there are things to do with this, of course. But now, the last 10 minutes or so, I'm going to switch to the next level of this type of manipulations. Yeah, so this is just to summarize, at least to some extent, we listen to ourselves to find out how we feel. So here, of course, when you do the experience we've shown so far with self-feedback, you're limited in how much manipulation you can make, both because when you listen to your own voice, so you shouldn't detect it, but also if you listen to your own voice, that puts a limit on how much processing you can do. But if you, on the other hand, switch it and use it as a social signal, you get much more leeway, basically. So if you set up an experiment in which you talk to someone over Zoom, you can do a lot more manipulations with the voice and other things. So we have developed sort of the next version of David called Duck Soup. It's called Duck Soup from this famous scene, and it's a movie, it's a Marx Brothers movie when he's standing in front of a mirror and the mirror is slightly off. And he's trying to trick the guy in the mirror, and you can almost sense that the guy in the mirror is sort of giggling or mocking him, but he still can't trick him. So this is something to aspire to. We would like something where we can have more control of what's happening, like if you were looking at a mirror that actually changed. Here, this is an online platform in which two people interact. And then going to do some sort of standard social psychology experiments like solving a problem together and so on. And they see each other through a Zoom channel and they hear each other. But here, not only are we going to manipulate their voices into different emotions, we're also going to manipulate their faces into different emotions. So there is an algorithm that will capture the outline of the faces and then either increase a smile going from here to here or decrease the smile. There's no good English word for unsmile, the opposite of smile. So frowning is something different, and there's nothing in Swedish either, but you understand what it means, the opposite of a smile. The Finnish smile, something. Right, so there is, so this is the ambition and some of the functionality. And now I'm going to switch to Pablo Arias. So if we worked with magicians creating choice blindness, here is the magician of audio and face manipulation and identification. So all of this is more or less his work, and so he used to be a PhD student with JJ. He's now been with us doing a postdoc for a few years, and he can do all sorts of things. Here he's going to show how this works. I wonder if we should turn off the lights. Yeah.
Okay, so it's demo time, and I want to show you a little bit how DocSoup works. And right now we are in the mirror version of DocSoup, so this means that I'm not seeing another person, but I'm seeing myself. Okay, and you're seeing some analytics. And basically, this is the my transformed video and audio. And here, this is my just direct from the webcam without any transformation. Okay, so let's look at this transformed version. Right now, all the effects are turned off. Okay, but what we can do, for instance, is try to increase my smile. For instance, sending a change of the parameter alpha of the algorithm, which is going to change in 600 milliseconds towards the smile manipulation. So when I click send, you should see myself smiling. Okay, so I think you saw that. Right now I'm smiling.
I feel that I smile when I look at him, like it's an intense contagion.
Again, for comparison, this is my non-smiling face. Again, my smiling face. And I'm making it 600 milliseconds so you can see the dynamics of it. What we can also do is take it to the negative side, so what we call the on-smile effect. Okay. So now you can see that I'm a little bit lowering the corners of my lips. Although when we look at my actual face, this is what it looks like. Okay, this is what my actual face. This is manipulated face. Okay, we are lowering the corners of the face. So for instance, if I take it off, it looks like this. Okay, did you see the subtle movements? Again, I'm going to do it a little bit stronger on smiling. Okay, so as you can see it. And now we're going to take it all the way up to the smile effect. Up, like this. Okay, so now I'm smiling a lot. I can do it a little bit more subtle, like this, for instance. Now I'm smiling a little bit more subtly. And I can add some sound voice manipulations. So now, for instance, I am pitching my voice upwards, a little bit upwards, and smiling a little bit upwards. So these are kind of congruent effects. Okay, I can take it a little bit further, like this, increasing even more the voice manipulation. And of course, what we can do is take it lower.
Go to the negative pitch shifts like this one, and of course I can add a non-smiling version to the face to be better accompanied by this pitch shifting. So right now I have like a negative
that one is really
smile,
natural.
So I'm unsmiling and I'm pitching
but
down.
But he sounds
a little
like
bit
he's
the pitch.
this
and
big.
As you can see, all these manipulations happen in real time, dynamically during the interaction. So right now I'm doing it to myself, but we could be doing it to two participants at the same time in different directions, right? And in the web.
So for instance, I can even lower my pitch even more like this. So this is very extreme. And I know you all want to see how it looks when I really push the algorithm for a lot. Like this is the full value, so you can see the corners of the face. The corners of the lips are actually shifted a lot.
Yeah. So he goes on playing with this for a while. Like he can't help himself.
A little bit fun. Yep.
Yeah.
So now -10, for instance, here. Wow. Okay.
I'm just playing with
the thing, just to show you the fact that we are manipulating dynamically and they have control of all things.
Yeah, I think we're done.
Yes. So let's go back to a more normal small manipulation here. And down. Yep.
Okay.
So now my
yeah, precis.
actual
You're no
face.
longer who knew. So, yeah.
And my neutral voice.
It could be a double bluff, so he's just pretending that one is.
So yep, that's all for me. Quick demo time of duck soup in mirror mode.
Brilliant. Right. So that is sort of the yeah, the ambition now, and as you can see, he's come quite a long way on it. But with this setup, when you have two people interacting, there is an enormous amount of things you can measure and you can play around with. So imagine they're doing a standard problem-solving task, this kind of ultimatum game, prisoner's dilemma, something when they interact, and standard social psychology setup. You can measure all sorts of basic behaviors. You can let independence raters look at their confidence, quality of conversation, all these things, how they are affected by the manipulations we apply. And of course, the main thing here is that we can isolate the effect of that specific variable. And that's sort of the golden bullet in psychology, that you want to isolate the one thing. So you can take that one up and down and see what happens to all the other measures. And this we can do. So you have all these things. You can then, of course, measure if it actually influenced the group decision or the outcome of the task and so on. Who is more listened to, who becomes more dominant, and so on and so on. But then you can also turn all his fancy stuff backwards. So you can use this, he's placed it around again. You can use this to analyze the face as well. So you can use the algorithm to analyze the stream afterwards and detect emotional expressions. You can also do eye tracking. This is sort of question mark is if it's possible, but it's going to be possible with web cameras as well. Online pupillometry. There are even experiments where they have learned to pick up heart rhythm from a face by this you can include. And then of course you have both these people. You can have all the analysis going to see when is a smile spreading, what's the effect, what's the synchronization, and on and on and on. And in an ideal world, you can just press a button and all this pops out because it's already there, because that's the sort of the stuff that analyzed the face from the beginning. So this is sort of in the startup phase. I've been talking for an hour. I'm just going to show you an experiment we have done, and this functions as a sort of a starting point because this scenario is quite obvious. So we have looked at attractiveness and expressive alignment. So expressive alignment is sort of one of these. It's also sort of standard psychological knowledge that you like people more if they mirror your actions. You get the advice to sort of sit with your legs crossed if the other person is doing it, and so on. And there are tons and tons of studies looking at imitation and alignment between people and what effect that has on people's performance. But this is then something we can study directly. And what we've done is to set up a speed dating experiment, which then is an actual speed dating with actual people, young heterosexual students in Paris in active romantic partner research, and they get to do a is it an 8? Yeah, they basically get to see all of the others on a 4-minute Zoom non-scripted interaction, as it is set up as an actual speed dating but over Zoom. But what's funny there is, of course, that we can set up both congruent and incongruent conditions. So we can have one in which one smiles and the other smiles as well, one where one smiles and the other is not smiling, and so on. So you can do all the conditions you would like by just changing the algorithm or the parameters in it when they start. And then you can measure if they want to see each other again and what's going to actually happen with their liking of the other person. This is a bit hard to see. So this is from an actual trial. These two people are talking. You can see that her smile is increased and his smile is decreased. And then you can follow the difference in her sort of the representation of the facial muscles and how that differs between the manipulation and the what she's actually producing, and so on. So this is sort of all the fancy stuff. We're sort of at the this was just an obvious test, and this one isn't actually online, so it's done with cables in different booths. It's using the same functionality, but it's not up and running. So the next step is, of course, to get it online so you can do all sorts of things. But we get some sort of interesting patterns. And this I'm bound to mess up because it's double negations all the way. But what we've looked at here is, for instance, we asked them afterwards, so to what extent do you think the other person wanted to see you again? So if you have an increased smile and the other person had an increased smile. So blue is increased smile and you are down here. So if you have increased smile, the other has increased smile, you're more likely to think that the other person is going to want to see you again compared to if the other person has a decreased smile. That kind of makes sense. But what's interesting then is this expressive alignment. So what happens when your face is decreased? And it seems to have some sort of effect, like when there is a mismatch between the expression you present and the expression the other person present, that influences how likely you think the other person will see you. This question is, it's more or less the same, but here's to what extent do you want to see the other person again? Again, makes sense. If that person is smiling, you're more likely to want to see that person again. Some interaction happens when you're so when both have a decreased smile, you're more likely to want to see that person again compared to when you're smiling and the other one isn't. And the last question here is, so was the conversation pleasant and interesting? There you get a quite nice criss-crossy effect. So that you think the conversation went better when the both of you had the same expression.
Even if it's decreased?
Yeah. So this isn't published, this is sort of just interpretation of what we're going, but it's interesting the fact that you can set up this. And you can do all sorts of interesting mismatches between a story someone tells. You can tell a happy story, but you can change the face or the tone of the voice to see how that influences. Okay, how sincere does this person sound if you do mismatches? Which one is the more dominant? And so when you start to think of it, you can just play around with this in infinity. So this is sort of the summary or the end slide of this presentation. Things we hope to be able to do in the future is, first of all, of course, put this online proper so you can run 4 participants at the same time, recruit them online. You use something called like a prolific or a mechanical Turk or this kind of thing. You do it full scale, so you can just schedule them, show up, interact, and then you do all the manipulations through a server, and it just happens. The next step I would love to add is to have this effect dynamic. So now it's just you turn the smile on and it stays on. But if you can do it throughout the trial, and then if you can set it at certain thresholds, for instance, so when the other person smiles, you automatically smile or something. So you can, what would happen if you reward the other person with a smile as soon as they smile, or as soon as they do whatever, say a certain word or something. Suddenly you can have this perfect control of social signals between two people interacting, which is, as a psychologist, it's sort of mind-boggling. You can just tweak everything and redo all social psychology with this tool. As I mentioned, imagine an ultimatum game. This is kind of game where you have one of the players gets a certain money, and you're going to send something to the others. They're going to send money back, and if they do, the money will sort of increase. But there's you have to have a certain level of trust, for instance, here. But what happens if you change the sound of the voice? Would that influence this dynamic or the trustworthiness aspect of your face, or whatever? You can actually try this and test it out. You can add things to the voice that would trigger certain implicit biases, see if that would make a difference, certain accents, certain whatever feature you're interested in. Basically. So the question we can discuss after the presentation is, yes, what do you think we should do with this tool once it's up and running? Imagine there are no technical hiccups and it just works as predicted. To sum up, this general approach that we follow, that's this self-knowledge, at least some of it comes from self-inference. We listen to ourselves to find out what we think, what we feel, what we want. This process is something we're quite often not aware of, at least not the extent of it. So it sort of ends up in the slogan that I like, that we know less about ourselves than we often think we do. And that's it. As I hope to have pointed out during the presentation, thanks to all the people that actually know how this works and so on. Right, and that's it.